Let's solve the following equation, trigonometric equation. Sine cubed x times 1 plus cotangent x plus cosine cubed x 1 plus tangent x is equal to square root sine x cosine x. All right. So first of all, let's find the domain. The domain is that sine x cannot be equal 0, cosine x cannot be equal 0, and sine x product sine x times cosine x also has to be greater than 0. So let's rewrite the equation in the following form. Sine cube x, let me this domain put in different color. There we go. Sine cube x times 1 plus cotangent, write down as a cosine x over sine x. Usually when you are solving equation, if you have different trig function, it's the best way to bring them to the same level, like tangent cotangent or sine cosine. So I chose to bring down to sine cosine because it's easy to work with and much more formulas are related to sine and cosine. Okay, cosine cubed x 1 plus sine x over cosine x, and that is equal twice sine x cosine x. Next, excuse me. So sine cubed x, I'm going to bring to common denominator this parenthesis, this one and this one. Okay, we need to get rid of this parenthesis. So it's gonna be sine x plus cosine x over sine x, right? Plus cosine cubed x, denominator is cosine x, so here we have cosine x plus sine x. And this is with this x at the square root, I'm bringing to the left part of equation. Sine x cosine x equals 0. Okay? So far so good, pretty straightforward, right? Moving on. So I'm going to cancel this. Here will be degree 2 left. Canceling cosine x, here will be left degree 2. And I'm getting sine square x sine x plus cosine x plus cosine square x cosine x plus sine x, and minus 2 square root sine x cosine x equals 0. Okay, so from here, as we can see, we have common factor, right? Sine x plus cosine x or cosine x plus sine x, doesn't matter at all. So if we take it out, sine x plus cosine x, So from the first term, I will have left sine squared x. From the second term, I will have left cosine square x and minus 2 square root sine x cosine x. And this is equal 0. All right, so this sine square x plus cosine square x is equal 1, which means it's going to be gone because it's multiplication, right? Tied up with multiplication. So hence we are going to get sine x. I am rewriting in the format that will be interesting to read. Minus twice sine x cosine x. And this plus cosine x I'm moving as a last one from here, this cosine x, and equals 0. Why did I rewrite this way? Look at that. It's going to be square root sine x squared minus 2 sine x cosine x and plus square root cosine x squared equal 0. Okay, this is giving us formula for perfect square, and that is going to be equal sine x minus square root sine x minus square root cosine x squared is equal 0. So from here, if we take square root from both sides, right? And from here we get sine x minus cosine x is equal 0, right? Which means sine square root sine x, oops. Okay, we got rid of this square root, right? And from here we can say that square root sine x is equal square root cosine x. Okay, or we can say, if we square again, right? We can say that sine x is equal cosine x. All right, if sine x is equal cosine x, and we have, that's a domain condition that and sine x and cosine x has to be greater than 0, right? Remember? Sine x has to be greater than 0. Cosine x has to be greater than 0. Therefore, I'm going to divide both terms by cosine x. Why? Because I'm getting tangent x is equal 1, where x is equal quarter of pi, right? From here, x is equal quarter of pi, and plus it's going to repeat every 2pn, right? Quarter of pi. Let me put here k. Okay? And from here, I can take pi over 4 out. If I take pi over 8 out, so from pi over k, if I take out, I'm going to get 8k, and plus 1. How did we get 8k plus 1? So 2 pi k, I divide by pi over 8, right? Because once you take common factor out, that means you have to divide the term by that common factor to see what left. And that's going to be equal 2 pi k actually times 8 and pi. Correct? Okay, this is gone. Here we are getting 16k k. Now, since I'm doing drafting, change the color. Now let's divide also pi over 4, divide by pi over 8. We want to know how much left from the pi over 4. It's going to be pi over 4 times 8 over pi, right? This is 1. This is also 1. 1 and 2. Here we are getting 2. So from here we will have pi over 8 we take out. From pi over 4 will be left 2. And from 2 pi k it's going to be left 16 k. Right? Okay. So if we take 2 out, we will have 1 plus 8k. And that's exactly what we have. Let me, might as well, since I did these changes, let me might as well move it here. Okay. I move this piece up. And from here, I can write down that x is equal. Let me see. This is 1, this is 4. And we have x is equal pi over 4, 8k plus 1. Okay? Where k is all a real number. And that is going to be k belongs to real numbers. And this is going to be our answer. Okay. Let me move pi over 4, first dividing by 2, move it here, because we take pi over 8 out, right? And this one also, and at the end we will have pi over 8 we take out, and we are getting the following result. Okay, so here x is equal, taking common factor, x is equal, reducing, combining, and we are getting this result. Next, we are going to solve the system of equations. We have sine x cosine y is equal square root of a. Sine x cosine y is equal 1. Okay, in one case I'm going to add these two equations, and in the other case I'm going to subtract these two equations. So first we are adding cosine x sine x cosine y plus sine x cosine y is equal square root of a plus 1. And second one, sine x cosine y minus sine x cosine y is equal square root a minus 1. Okay? All right. And we see that represents formula, because if I rewrite, I will get the following the formula: sine x cosine y plus sine x cosine y is equal sine x plus y. Accordingly, sine x cosine y minus sine x cosine y is equal sine x minus y. Okay, so from here I can write down that sine x plus y is equal square root a plus 1, and sine x minus y is equal square root a minus 1. Right? Okay, since we are dealing with sine x, cosine x, it is legit to assume a is equal 0, right? Because we don't need any shifting. Therefore, this way I'm going to get sine x plus y is equal 1, and sine x minus y is equal negative 1. Okay, so if sine x plus y is equal 1, where do we get x plus y equal 1 for sine? It's at the point it gets 1 when it's half a pi, right? And then plus 2 pi again. Yes? And then plus again 2 pi. Therefore, we are going to get x plus y. It's going to be equal pi over 2. This is here our pi over 2 for sine, right? And plus 2 pi n, because it's going to repeat every 2 pi n times, right? And x minus y, same way. We have negative 1, so this is going to be this point, and plus 2 pi n. It's going to be 3 over 2 pi here, or I'm going back here, starting from negative, it's going to be negative half a pi, right? Is equal negative half a pi plus 2 pi k, where n and k are real numbers. Okay? N belongs to real numbers, k belongs to real numbers. Okay, so what do we have here? Solving this equation, we are getting 2x is equal, this is also canceling, right? And we are getting 2 pi n plus 2 pi k. Okay, dividing by 2 both sides and taking pi out as a common factor, we are getting x is equal pi times n plus k. Okay, and this is our answer.